Let us discuss about the MIME content types. The bulk of MIME specification is concerned with the definition of a variety of content types. This reflects the need to provide a standardized way of dealing with a wide variety of information representations in multimedia environment. The table towards the left hand side lists the content types specified in RFC 2046. There are seven different major types. There are seven different major types, and 15 different subtypes have been given over there. In general, a content type declares the general type of data, and the subtype specifies a particular format of the data type, or the format for that type of data. Let us discuss about one by one. The first one, for the text type, no special software is required to get the full meaning of the text aside from supporting of the indicated character set. The primary subtype is a plain text, which is simply a string of ASCII characters or an ISO, which have been declared in the ISO 8859 characters. And the second one is going to be enriched, which is a subtype allows a greater formatting flexibility, and which is provides the format flexibility for this particular text. The second one, multi-part. The multi-part indicates that the body contains multiple independent parts. The content type header field includes a parameter called as a boundary that defines the delimited between body parts. This boundary should not appear in any part of the message. Each boundary starts on a new line and contains or consists of two hyphens followed by the boundary value. The final boundary, which indicates the end of the last part, also has a suffix of two hyphens. Within each part, there may be an optional ordinary MIME header. Let me see an example of this particular multi-part later after this slide. There are four subtypes of this multi-part, which are all of which have the same overall syntax, which is going to be called as multi-part mixed, multi-part parallel, multi-part alternative, and multi-part digest. So let us discuss about one by one. The multi-part mixer. The multi-part mixer subtype is used when there are multiple independent body parts that need to be bundled in a particular order. Second one, the multi-part parallel. The multi-part parallel subtype, the order of the part is not significant. If the receptant system is appropriate, the multi-part can be presented in parallel. For example, a picture or a text part could be accomplished by a voice commentary that is played while the picture or a text is displayed. The third one, the alternative, multi-part alternative subtype. This multi-part alternative subtype is the various parts or different representations of the same information, which is a different parts of alternative versions of the same representation of the same information. They are ordered in increasing faithfulness to the original, and the receptant mail system should display the best version of the user. Then the fourth one, the digest, multi-part digest. The multi-part digest is used when each of the body part is interpreted as an RFC 5322 message with header. This subtype enables the construction of a message. Those parts are individual messages. For example, the moderator of a group might collect email messages from participants, bundles these messages, and send them out in one encapsulating MIME message. The next one is a message type. The message type provides a number of important capabilities in MIME, which has a subtype of RFC 8222, partial and external body. Let us discuss about one by one. The message RFC8222 subtype indicates that the body is an entire message, including a header and a body. Despite the name of this subtype, the encapsulated message may not be only a simple RFC5322 message, but also any MIME messages. The second one, message partial. The message partial subtype enables fragmentation of a large message into number of parts which must be reassembled at the destination. For this subtype, the three parameters are specified in the content. In the content type as message partial field and ID common to all fragment of the messages of the same message, a sequence number unique to each fragment, and the total number of fragments. The third one, under message external body. The external body subtype indicates that the actual data to be conveyed in this message are not contained in the body. Instead, the body contains the information needed to access the data. As with the other message types, the message external body subtype has an outer header and an encapsulated message with its own header. The only necessary field in this outer header is the content type field, which identifies this as a message external body subtype. The inner header is the message header for the encapsulated message. The content type field in this outer header must include a access type parameter which indicates the method of access, such as file transfer protocol. Next type, image. Under image, it is going to be a subtype called as JPEG and GIF files. The image in the JPEG format or JFIF encoding formats, whereas in the image in GIF, the image is going to be there in the GIF formats. And videos are going to be there in the MPEG format. It may be an MPEG formats will be available over there. And audio basic subtype is going to be called as a basic, and it may be a single channel 8-bit ISDN MULA encoding at a sample rate of 8 kilohertz. And the last one, or the seventh type of MIME content type, is nothing but application. Is called as application. The application refers to other kind of data, typically either uninterrupted binary data or information to be processed by a mail-based application. In this particular application, the two data are going to be present over there as a PostScript and octet stream. The PostScripts are going to be in Adobe PostScript formats, and octet stream are going to be generally a binary data consisting of 8-bit bytes. These are the 7 types of MIME content and 15 subtypes of MIME contents. Let's have a small example of this particular MIME message structure. What actually the message structure is going to be? The message structure, multi-part message structure, is the outline of a complex multi-part message. The message has 5 parts to be displayed serially: 2 introductory plain text parts and embedded multi-part message, a rich text part, and a closing encapsulated text message in a non-ASCII character set. The embedded multi-part message has 2 parts to be displayed in parallel: a picture and an audio fragment. This is an example of this MIME message structure with a multi-part example, which consisting of a from, to, subject, and MIME version, and a multi-part which is consisting of a boundary, a mixed multi-part mixed subtype consisting of a boundary, and within the boundary the contents are going to be present over there, and which has been specified with the example over here. Next we will move on to the MIME transfer encoding. What actually the MIME transfer encoding? The other major component of MIME specification, in addition to the content type specification, is a definition of transfer encoding for message bodies. The objective is to provide a reliable delivery across the largest range of environments. The MIME standard defines two methods of encoding data. The content transfer encoding field can actually take on six values. We can see in the table which have been given over here. The six values have been mentioned over there. However, three of this as a 7-bit, 8-bit and binary indicates that no encoding has been done, but provides some information about the nature of the data, which is going to be for SMTP transfer. It is safe to use 7-bit form, and 8-bit and binary forms are maybe usable in other mail transport content. Another content transfer encoding value is called as an X token. The X token, which indicates the some other encoding scheme is used for which a name is to be supplied. A user can give the name for this particular encoding process. This could be a vendor specific or application specific scheme. The two actual encoding schemes defined are quoted printable and base 64. Two schemes are defined to provide a choice between a transfer technique that is essential human readable and one that is safe for all types of data in a way that is reasonably compact. Let's discuss about the quoted printable transfer encoding, which is useful when the data consists largely of octet that compressed or corresponds to printable ASCII character. In essence, it represents non-safe characters by the hexadecimal representations of their code and introduces reversible link breaks to limit a message links to 76 character. The second one, the base 64 transfer encoding, which is also known as radix 64 encoding. It is a common one for encoding arbitrary binary data in such a way as to be invulnerable to the processing by mail transport programs. It is also used in PGP. Already we have come across in that one. Let's see how this is actually it's going to be used in the for future references that we will see later. Next, we can move on to the canonical form. The canonical form is a format appropriate to the content type that is standardized for use between the systems, and this is in contrast to native form, which is a format that may be peculiar to a particular system. The table which is going to be the left side, the table which is going to be describes the particular native form and the canonical form. In the native form, the body to be transmitted is created in the system native format. The native character set is used, and when appropriate, local end of line conversions are usually used as well. The body name may be an unique style text file or a sun raster image or a VMS indexed file or audio data in a system dependent format stored only in the memory, or anything else that corresponds to the local model for the representation of some form of information. Fundamentally, the data is created in the native form that corresponds to the type specified by the media file. The canonical form, the entire body including out of band informs information such as record, length and possibility file attribute informations is converted to a universal canonical form. The specific media type of the body as well as its associated attributes dictates the nature of the canonical form that is used. A conversion to this proper canonical form may involve character set conversions, a transformation of audio data, compression or various other operations specific to the various media types. If character set conversion is involved, however, care must be taken to understand the semantics of the media type, which may have stronger implications for any character set conversion. Example with regard to syntactically meaningful characters in a text subtype other than the plain. This is about an important concept of MIME and SIM